Okay guys, so now in this video we are gonna write the code for k-means, and it is going to be pretty easy. So let's start. First of all, let me import numpy as np, and let me also import matplotlib dot uh, pyplot, or from matplotlib import pyplot as plt, and let me also download some data set. Okay, so from sklearn dot data sets import make underscore props. Okay, so let's make our x and y, and we are not going to use y, but we have to get the value from this other class, otherwise it is going to what do we say, it is going to raise an error. So for this, make flops, okay, and samples equal to 500, and samples equal to 500, and centers, I want centers to be 5, so I will explain you what I am doing here, and you can choose any random state. So let's take random state as 3. Okay, so we have x and y, so let's take plot dot figure 0 and plt dot grid 2, plt dot scatter. I want all the values of 0th column, and I want all the values of first column, and I want to give the color map as y, so c equal to y. So now you can see here that we have 5 groups, but I have only colored them because right now I just wanted to show you that we have 5 groups. If you do not want to color them, it is up to you, and you can just remove this line, so it will look like this. But if I am just using the y to show that these are 5 different groups. Okay, so let's do c equal to y. Okay, so the next step that we need is we need to assign some random points. So as we have 5 clusters, what we are going to do, we are going to get 5 new points. Okay, as I told you in my last video, in that video I took the example of 2 clusters, so we had 2 points, but in this video we have 5 clusters, so we are going to take 5. So it means that our k is going to be 5, and let's set the colors, that what color we are going to give. So let's take green, red, blue, yellow, and orange. So cluster equal to on this. I will just explain you in a minute what I am doing. So for I in range k, okay, so center is going to be 10 times 2 times 2 into np dot random x dot shape 1, comma, yeah, we need to pass this as a tuple here, and this. So what is this line doing here? First of all, you should see that, okay, we have the range from -10 to 10. Okay, I hope that it is clear, or it is visible. So but the range is from -10 to 10. So what I'm going to do here, let's suppose what we are going to get is this. Let's see. So as you can see here, we are getting uh, two values. Okay, so this is going to work as x0 and this is going to work as x1. Okay, now what we are doing is we are going to multiply this with 2. So these values are between in the range of 0 to 1. Okay, now this value is going to be multiplied with 2. So 1, this is going to be 0 to 2. Okay, now it has gone from so this part will create values from 0 to -2 or 0 to 2. Okay, and then we are going to uh, subtract 1 from this range. So this is going to be -1 to 1. So this is our new range. Okay, and then we multiplied it with 10. So our new range is going to be 10 -10 to 10. So the new range is -10 to 10. So what is going to happen, that we are going to get the values anywhere from this part to this part. Okay, we are going to get some values from this range to, from -10 to 10. So they are going to be our random center. Okay, and then points is going to be nothing but empty list. So, and what is going to be the cluster is going to be center points and colors clusters. This is also going to be clusters. So clusters dot I is going to be cluster. So what I am doing here is I am creating 5 new points. Okay, I am creating 5 new points, and what it is going to do, so let me just give you an example. So let's suppose we have some points here. Okay, and let's suppose we have some points here. So what we are doing here is we are saying that we are creating new points. Let's suppose a point is here and a point is here, and this is the center. Basically these are the center, so we are creating them randomly. Then we are going to assign some points to them. So to this cluster, to this center, these points are going to be assigned, and to this center these points are going to be assigned. But right now it is empty, and what we are saying, okay, we have a cluster in which we have a center like this. We have all these points, and we are going to set a color of this so that it is easy to visualize. So let me just show you what we have done here right now. So if we'll run this, okay, so K is not defined. I've used a capital K here. And if you will see what is clusters, so we have cluster 0 in which the center is here. We do not have any point and the color is green. Then we have the first cluster in which the center is here. Now we do not have any point right now and the color is red. The third point, the second point is the center is here. The point, we do not have anything right now and the color is blue, and so on. So this is what we have done. Now what we are going to do, we are going to define a function to measure the distance of every point from the center. Okay, so what we are going to do is def distance v1 to v2, that is vector 1 from vector 2. Okay, and it is going to be returned np dot sqrt square root np dot sum v1 minus v2 square. So this is nothing but this is our Euclidean distance, and we have also done this in KNN, so you can just look for that. So this is going to be our uh, distance. Now what I'm going to do, I am going to create some function. So that is going to be, let's first assign all the points to the function. So def assign points to clusters. In this we are going to pass clusters. So what I'm saying, for ix in range x dot shape 0. So what I am saying here is that, let's suppose we have created 5 points, 1 2 3 4 5. Okay, so what I am saying that we have to find the distance. We have to find the distance, because what we have to do is we have to assign some points to this cluster, some points to this cluster, some points to this cluster, some to this, some to this, something like this. Okay, we have to assign all of these points. So what I'm going to do here, I'm going to find the distance of every point. Like, I'm going to find the distance of this point, this point, this point, from every of these centers. So first of all, I'm going to find the distance from this, this. Similarly, I'm also going to find the distance from this, and as all of these points are closer to this center, so we are going to assign these points to this center. Okay, I hope that it is clear now, but if it is not clear, just try to do it by yourself, like by hand, and you will understand that what I am saying here. So we are gonna go through all the points. We are going to make a distance list, and current x is going to be x dot ix. So this is our current x, it means this is our current point. Now what we are going to do is we are going to find the distance of this point with every other point, every other center. So for kx in range k, as our k is 5, so we want to find every point with every center. Okay, and what I'm going to do is t is equal to distance. I'm going to find the distance of the current x and the cluster kx and center. So what I am saying here is that I want to find the distance. So the current point, let's suppose we have this, we have this, we have this, we have this, and we have this, we have this, we have this, we have this. So these two are our centers, and these all are the points. So what we are doing here is, we are taking the first point. Let's suppose we are taking this point, then we are using both of these centers, and what we are doing is t equal to distance. So we are finding the distance between this and this point right here and this center. So how we are going to find this center? As we have seen clusters, so cluster, let's suppose cluster 0, as we have sent here, cluster 0 0, and in this our center is this. So this is the basically this is the position of this center. So we are going to find the distance of this center. Then the slope is again going to run, and we are going to find the distance of this center. And as this this point is closer to this center, it is going to assign to this center. Okay, now similarly for let's again we are going to do with this, then with this, then with this, and as all of these points are closer to this center, then these all points are going to be assigned to this center. For these points, these are closer to this center, so these are going to be assigned to this center. Okay, I hope that it is clear. Otherwise it is a very basic code. I hope that it should be clear. Okay, so distance dot append d, and what I am saying is current cluster is going to be np dot argmin dist distance. So cluster, current cluster points dot append. So what we have done here is these points. Okay, so we have find the distance of this point to this center and to this center, and we have appended it to distance. Now what we are doing is uh, we are finding the location, or the not the location but the position of the minimum point. So as this is the minimum point, so we are getting the index. So let's suppose this x has find the distance with this. So in the distance we had let's suppose the distance as 5, okay, for this, and then we had the distance 10 for this. So this was 0, this was 1. So when we are finding this part, what we are doing here is we are saying okay, we are returning 0, okay, and then we are saying this is our cluster. So what we want to do is we want to in the cluster, not the cluster but the clusters, in the clusters. So what we are saying, in the clusters we need the 0th cluster, it means the 0th center, and in this we are going to append the point. So this point is going to be append to this center, okay. I hope that it is clear, because it is very hard to explain something when there is no cross questioning, and you do not know whether it is clear to someone else or not. But if you have any doubt, you can ask me in the comments. Okay, so cluster is going to be this. So this is how we are going to assign every point to our clusters. Okay, so we are going to make clusters like this. Okay,